loan calculators. Some of them are really, really accurate and some of them aren't. But you can enter your own information. So for example, you can enter that you want to take out a $100,000 loan. Say you want to buy a house, right? For an annual percentage rate of, I don't know, 7.5%. And then let's say you want to take it out for 15 years. And you enter all this and then you get out info. Okay. And then, like I said, some of them are really accurate and some of them aren't. And then some of them include even more information that we haven't gone over, like PMI rates and things of that nature that are all part of the mortgage process. All right, so let's figure out this problem. We're going to determine the total interest owed on a 5-year $10,000 loan at 6% interest. So R T P. Yes, you could do this one with the table, but I'm going to do it with the formula just to give you guys more practice. We can't do it on the table? It doesn't have a 6% on there? Oh, you're right, you can't do it on the table. Okay. Oops, that's not a parenthesis. -1. Okay, so 0.06 divided by 12 is 0.005. So this becomes 10,000 times 0.005 times 1.005 to the 60th times 1.005 to the 60th minus 1. Now, one thing that I want to point out, if you're taking out a 5-year loan, you're making 60 payments. So this exponent also ends up being how many payments you make. So that's just kind of like an interesting little thing that happens. So I take 1.005 and I raise it to the power of 60. And I get 1.348850 stuff and more stuff. I multiply that by 0.005, and then I multiply that by 10,000. And I get 67.442 and more stuff. And then I take 1.005 to the power of 60 again, subtract 1, and then that gives me 0.34885 and some stuff. So my payment on this particular loan, a $10,000 loan for 5 years, is going to be $193.33. That's my payment. But I want to know what my total interest owed is. So I take that payment, 33, times the number of payments to get how much I'm actually going to pay. So this is how much I paid. And from that, I'm going to subtract the original amount that I borrowed. And this is interest. Okay, so you borrow $10,000, you pay back $11,599.80, so your interest is $1,599.80. Another scenario, you can determine, okay, I need to borrow a set amount of money. I can only afford to pay so much a month. How long would the loan have to be to make the payments that low. Because the shorter the period of time on the loan, the bigger your payments are going to be, right? Does that make sense? So we can determine using the loan length formula how long the loan has to be. Now this right here, ln, that's the natural log. And it's a mathematical function. It's also a key on your scientific calculator. Okay, and the way it works on my particular calculator, and it should be the same for everybody else, is if I push ln, I get a parenthesis. So I push ln, I get a parenthesis, I put in the number, and then I close the parenthesis, and then I'll get my answer. I press enter and get my answer. So you have the ln button.
Oh, and it also might be negative infinity too.
Do what?
On the iPhones, a negative infinity will pop up instead of a
infinity.
Yeah.
That's weird.
Yeah, right.
Okay. But you have an ln button on the calculator, okay? That's natural log. So it's not, the L and the N don't stand for like compounding in length or anything like that. It's an actual button on your calculator. Okay, huh? Got it? Okay. So M is the amount you can afford. Wait, hold on. I got big M and little m. Let me just double check myself. Nope, there's a typo. That should also be a big M. Sorry about that. Can you guys, you want to fix that so that you know it's the same M? Okay, so this is the amount of desired payment, or desired payment amount. You know, how much you want the payment to be. Okay, P is the total amount you're borrowing. And then, of course, R is still the rate. Okay, and the natural log is just the natural log button. That's a function. Okay, so I'm going to enter in. Claude wants to pay $300 a month. That's all he can afford to pay. But he wants to borrow $25,000. So $300 a month, borrowing $25,000 at 0.059 divided by 12. And the reason there's double parentheses in there is because I need to do this math first before I take the natural log of it. Okay. And then I have 12 times the natural log of 1 plus the rate divided by 12. Okay, so I'm going to do this first and this second. And then I'm going to do the whole thing third. And I'll take the natural log of it, that's fourth. Like in this bracket. So you have to do the division and the division, and then the subtraction, and then do the natural log of whatever number you get. Here I do the division first. Let me do a different color. For this part, I do the division first, and then I take the natural log of it. For this part, I do the division first. Different color. Sorry, trying to make it make sense. Then I add second, and then I take the natural log of it third, and then I multiply by 12 fourth. So divide, add, natural log times 12 to get the bottom number. So
the log applies to the value in the middle. It doesn't apply to the 12. Really.
No, the 12 gets multiplied times the log. Okay. Does that help?
Yeah, because like I'd be seeing with like the parentheses, you know what I mean, separating it.
Yeah.
Okay.
So if you want, you can put like a little times in there if that helps. So I have the natural log, so I'm going to do 300 divided by 25,000. And that's 0.012. Minus the natural log of all this. So that 300 divided by 25,000 I already did. So I'm going to do 0.059 divided by 12. And then I'm going to subtract them. So I get 0.012 minus 0.004916 forever. And that gives me 0.0071. Okay. And then I have 12 times 1 plus. So 0.059 divided by 12 is 0.0049. Okay. Now I'm going to take the natural logs of everything. So again, that's a button on my calculator. I've got natural log of 0.012. Yeah. No. No. LOG and LN aren't the same. So then I do the natural log of 0.0071. So natural log 0.0071. And that's another negative number, negative 4.948. And then I have the natural log of 1.0049. But I'm going to have to do 12 times that. Hold on. I put my decimal in the wrong place. Too big. So I'm going to 12 times 0.004888 stuff. Okay, minus a negative becomes a positive, so I have 4.94888 minus 4.4228, and I get 0.52608. And when I multiply this times 12, I get 0.058656. And then I divide. And I get 8.9 stuff, so we're going to say 9 years. What? No. Let's just make up one. How much do we want to borrow?
$5,000.
Really? Just $5,000?
Yeah.
Okay, we're going to borrow $50,000. And what's our interest rate? We'll just say our interest rate is like 6%. How much can we afford to pay per month?
Like 500.
500 a month? Okay. So all right, so our monthly payment is going to be 500. We're borrowing 50,000. And our rate is 6%. All right, so here's what I'm going to do. I'm going to do this in stages. So 0.06 divided by 12. That number right there is 0.005. Okay. And 500 divided by 50,000, that's 0.01. And then 0.01 minus 0.005 is 0.005. That's convenient. Natural log of 0.01 is negative 4.60517. Natural log of 0.005 is negative 5.2983. And the natural log of 1.005 is 0.0049875. Okay. Guys, I'm not doing this for me. I know how to do this. So this is, if I get a chance to. I mean, I always try to, but the computer doesn't seem to be cooperating today.
For the pawn shop questions on the homework, what formula do we use?
You don't. Hold on. Remember, I can only do one thing at a time today. And right now I'm in the middle of a problem that I'm doing for apparently no reason whatsoever. It would take 11 and a half years to pay off that loan. If you kept